Hello, Leiden geometry students. In this assignment, we're going to talk about polygon angles. Those are angles inside and outside of some of our basic shapes. For example, this one here is a seven-sided shape called the heptagon or septagon. Here, we want to talk about the angles on the inside, interior angles. When we talk about the angles inside a shape, we have a formula to figure out what they add up to. What's their sum, as we call it. And their sum is n minus 2 times 180, where n is just however many sides the shape has. In this case, it's a seven-sided shape, so we plug in 7 for n. 7 minus 2 times 180, and we'll get 900. This is the beginning for all the problems that involve interior angles. When we talk about the angles outside the shape, or exterior angles, that's these in the same shape here, well, we don't have a formula for that. They just always add to the same number. Our exterior angles always add to 360 degrees. No matter what the shape is, a pentagon, a decagon, a 43-agon, they always add to 360. So interior angles basics and exterior angles basics. Whenever we do interior, you need to use that formula. Whenever we do exterior angles, we start with 360. All right, one other little shortcut that's going to come up a couple times here is if we take a look at our interior and exterior angles in any shape, in this case it's a decagon, but it doesn't matter what shape it is, for any shape, a pair of interior and exterior angles always make a straight line together, and so each interior angle with its exterior angle pair are always going to add to 180. That's going to be a shortcut that's going to help us in some of the harder problems in just a few minutes. All right, so let's start with the basic problems. The basic problems give you a shape, and we just ask you, what do the interior angles add up to, or what do the exterior angles add up to? These are the most basic problems. All right, so you'll notice that there's no picture in either of these problems. Without a picture, then we're going to have to pay special attention to the words. So the first thing you want to look for in every problem is whether or not we're looking for interior or exterior. This first problem here says the interior angles. If we're doing interior, that means we're going to use this formula. This formula tells us what they add up to, or what their sum is. To use this formula, the next thing we have to look for is how many sides the shape has. Well, this one says it's a nonagon. You have to know that a nonagon means it's got 9 sides. Okay, if we want to know what the angles inside a 9-sided shape add up to, we just plug them into our formula. 9 minus 2 times 180. And that's going to give us 1,260. All right, second problem is done almost the same way. Take a moment, see if you can find the sum of the interior angles in a 13-gon. Okay, first off, it's interior, so we're going to use our interior angle formula. And it's got 13 sides, so we're just going to plug 13 into that formula. And when we do that, we'll get 1,980 degrees. The other two problems are a little bit different because now we're asking about exterior angles. When we talk about exterior angles, we no longer need the formula because the exterior angles add up to 360. So what's the sum of the exterior angles in a 40-gon? It's 360. What about the last question? What's the sum of the exterior angles in a triangle? Actually, you don't even have to know what the shape is. If it's the sum of the exterior angles, it's going to be 360. Now, we have already talked about those kind of problems in a previous assignment, but now we're going to talk about our first type of new problem. We're going to run into a couple types of new problems. And here's the first one. Here in this shape, we have a 5-sided shape. It's a pentagon. And we know what most of the angles are, but not all of them. We're going to have to try to find x here. So to do that, we have a few things we have to figure out. Number one, we're going to figure out how many sides it has. We've already said it's a pentagon. Two, we got to decide if we're looking at interior or exterior angles. That's kind of always one of the first things you do. And then we'll figure out what these angles are supposed to add up to. So it's a pentagon with 5 sides. Interior angles means we use our interior angle formula to see what the angles add up to. And in this case, our angles are going to add up to 540 degrees. Okay, so we know these angles add to 540. And yes, I know this picture's not to scale, but that's okay. So we know that these 5 angles add up to 540. Well, that becomes the equation we're going to write and ultimately solve. We're going to take all these angles, add them up, and make that equal to 540. So 103 plus 85 plus 121 plus 68 plus x is 540. All you have to do is combine like terms and solve for x. And we should end up with 163 for that missing angle. Now, this is an interior angle problem. We can have the exact same kind of thing going on with an exterior angle problem. It would look something like this. Here again, we have all these angles, and we just got to figure out what they add up to and write an equation that represents that. So first thing we notice is it's a pentagon with 5 sides, and these are exterior angles. We don't have to use a formula because exterior angles automatically add to 360. So that's going to be our equation. These angles, put pluses between them, and that equals 360 degrees. So our equation would be 70 plus 60 plus 65 plus 40 plus y is equal to 360. And again, simply combine our like terms to solve for x. And very quickly, we should end up with y is equal to 125. Now, this is a basic kind of problem. It's still not very tricky. We're going to take this and we're going to make it a little uglier with too much algebra in just a second. But if we're talking about interior angles, we got to figure out what they got to add up to, and then just write an equation that says these angles add up to that number. When it's exterior like this problem, well, these always have to add up to 360. So just create an equation that says that, and then combine like terms and solve for x. It's important to try to do that problem this way. I know people will think of shortcuts, but the shortcuts you come up with probably won't work on the second type of new problem, which looks like this. Okay, so now we don't just have one x, we got a whole bunch of things. So the shortcuts you may have come up with in that last problem aren't really going to work here. We want to stick with the way that we were talking about this. The first thing we want to do is identify our shape, how many sides it has, and we want to decide if we're looking at interior or exterior angles. This is a hexagon with 6 sides, and we're looking at interior angles. So since we're talking about interior angles, the first thing we're going to want to do is figure out what they add up to. So we use our interior angle formula and find the sum of the interior angles. And in this case, it's going to be 720. All these angles in the picture add up to 720. By the way, when you do this, make sure that you include that this little angle here with the box, that counts as a 90 degrees. Now, since we know these add up to 720, we're just going to write that equation. Angle plus angle plus angle plus angle plus angle plus angle equals 720. And we get a big, nasty-looking equation like this, but it really isn't so bad because all you have to do is combine like terms, and then it's a two-step algebra problem. So if we combine our like terms, we're going to end up with 8x plus 320 is equal to 720. And then we simply subtract 320 from both sides, then divide by 8. And we'll end up with 50 in this problem. The algebra gets really big and ugly with a long equation like this, but it really shouldn't be too difficult. Let's try another one, but this time we're looking at exterior angles. Since we're looking at exterior angles, that actually makes the problem easier because we don't need a formula to figure out what they add up to. These angles are automatically going to add to 360. If you start the problem the same way, you'd count up the sides and say, okay, it's a heptagon, 7 sides, and we're looking at exterior angles. But you don't actually have to figure that because since they're exterior angles, they have to add to 360. So all we got to do is say all these angles, put a bunch of pluses between them, and say that's equal to 360. And if you do that, you get a big, nasty-looking equation like this. But then once you combine your like terms, it just gets a lot easier. We should end up with 9x plus 225 is equal to 360. And then simply subtract 225 and divide by 9. We'll end up with x is equal to 15. Now the third type of new problem. The third type of new problem has to do with the shape being a regular polygon. Here we have a regular hexagon. Forgot what that word means? No problem. If it's regular, that means all the sides are the same, so all these sides have the same length. If you knew the measure of 1, you'd know them all. But we're not really talking about sides here. We're talking about angles. And all the angles in a regular polygon are congruent as well. That means every angle has the same measure. Instead of putting little marks in the picture, I'm going to put a number. I'm going to call it x. But if one of them is x, they're all x. So we have essentially this picture, and we're going to try to solve for x. The way we do it is still the same way as all the other problems. We're going to figure out what they're supposed to add up to, write an equation, and solve. Step 1, what are these angles supposed to add up to? We're going to, whoa, I got an error there. Hang on. There we go. So what's the sum of these angles? No problem. We just use our n minus 2 times 180 to figure out what they're supposed to add up to. In this case, 6 minus 2 times 180 will give us 720. So that's what these angles are supposed to add up to. Now, what we really want to find out is what's the measure of each one. No problem. We can write an equation like we did in the last one. There's a shortcut coming, though. If you see it, go ahead and use it. Write an equation and solve for x, or use a shortcut if you see one. All right, the long way to do it is to write x plus x plus x plus x plus x plus x is equal to 720. But when you combine like terms, it's going to simplify down to 6x. It's a hexagon, so there's 6 of these things. If it was a pentagon, it would be 5x. If it was a decagon, it would be 10x. And that's always the case. The number in front of x ends up being the number of sides the shape has. So our last step here is to simply divide by 6. And in this case, we get 120. But there was a shortcut if you can combine these 2 steps. Because it's always the same number that you plug in for the number of sides that you end up dividing by at the end. We could just skip all the steps in between, find out what they're supposed to add up to, and then just divide by how many there are. And that will work every time to find the measure of each angle. Let's try that on another problem. Here's an octagon. All the angles are the same, and there's 8 of them. What's the measure of each angle since it's a regular octagon? Okay, find the total. what they're supposed to add up to, and then simply divide by the 8 angles. If you do that right, we start off, we could use this formula. If you're a formula person would prefer this. You do 8 minus 2 times 180, that's going to give you 1,080. And then we're just going to divide that among 8 angles and get 135 for each one. You can try that again with a regular 15-gon. Now the picture's gone. It's okay, we don't need the picture for this. We're simply going to find out what the angles add up to and then divide that equally among each angle. So start, what do these angles add up to? Then divide that by how many there are. If you do that right, we do 15 minus 2 times 180, that gives us 2,340. And we're just going to divide that among 15 angles, which will give us 156. Now, the interior angle problems, these aren't really that hard. They're even easier if we talk about an exterior angle problem. Well, if we have the same polygon, but now we talk about the exterior angles. Well, it's basically done the same way, except we don't have to worry about finding out what they add up to in the first place. They add up to 360 because they're exterior angles. So all we really have to do is the second part of the problem. We're going to take the total, 360, and divide that by how many angles there are. And in this case, we're going to get 24 degrees. Each angle would be 24 degrees. Now, I want to remind you of a weird shortcut that's going to help us with a hard problem. An interior angle and an exterior angle are supposed to add to 180 if they're next to each other. But in a regular polygon, they're all the same. So any interior angle and any exterior angle would add to 180. So in this case, instead of, you should know that these two angles, the interior and the exterior, these two angles add to 180. So if you found one of them, you could find the other one by simply subtracting that from 180. See, we could use that in a harder problem like this, which turns out to not be a hard problem. In a regular 30-gon, what is the measure of each interior angle? What's the measure of each exterior angle? Well, the exterior angles are easier. We're just going to take 360 divided by how many sides it has. 360 divided by 30 will give us 12. Each exterior angle measures 12 degrees. To do the interior angles, you can go through all the steps, or just make sure it adds with 12 to make 180. Just 180 minus 12 is going to be 168. These two angles add to 180, an interior and exterior angle in a regular polygon. Okay, our last type of problem. The last type of problem is going to be backwards. We're going to tell you what an angle measures and then ask you how many sides the shape has. But it turns out it's kind of done the same way. See, our question here says a regular polygon has exterior angles that measure 10 degrees. How many sides does it have? Well, if it's a regular polygon, if we knew how many sides it has, we would take 360 divided by however many sides, and that would give us 10. It would look something like this. But if you look at this formula, we've dealt with formulas like this before, where we can simply swap these numbers and it's still true. So we can take 360 degrees divided by 10 degrees, and that'll tell us how many sides it has. So how many sides will this polygon have? It's got 36 sides. Pretty easy to do that. So if you're given the measure of an exterior angle, just 360 divided by that will tell you how many sides the shape has. Okay, so a slightly harder version of this, what if I tell you what the measure of an interior angle is? Okay, this can be a little bit tricky. You could do the n minus 2 times 180 divided by n equals 160 and try to solve for n. Or, since we know what the interior angle is, we could just figure out the exterior angle and do it the same way as the problem above. So if the interior angle is 160, what's the measure of an exterior angle? It has to be 20 degrees. Now this problem is the same as the one above. We know the measure of the angle. We just want to know how many sides it has. So normally 360 divided by the number of sides would give us the angle. We're going to switch them and say 360 divided by the angle will tell us how many sides it has. And this has 18 sides.